Hi, I'm KHIVISHA Mohan. My metric number is B0820100327. Today we are going to explain about our mini project. Before diving into the details of our mini project, let me introduce the talented individuals who have worked with me in this mini project. Tommy Lee CHUIN, Mohamed HAFIZY bin SHAHARUL NIZAM, and Mohamed IRFAN bin Mohamed MOTARI. The objective of our mini project is to design and construct a real-time system using an Arduino board that incorporates with a variable resistor and LDR sensor for input voltage measurements. Second is to implement the control logic to control the LEDs based on the measured voltage values from the variable resistor and LDR sensor. Third is to demonstrate the ability to display measured voltage value and task execution details on the serial monitor for monitoring and debugging purpose. Then, apply scheduling principle to assign suitable period and priority to the system task to ensure smooth and timely execution within the Arduino real-time environment. Introduction. In this project, we focus on the creation of real-time system using Arduino and RT. The system involves hardware components such as LDR sensor and variable resistor, as well as the software logic. The LDR sensor utilizes light to modify the input voltage on analog input pin, while the variable resistor controls the input voltage entering the Arduino through another analog input. By measuring the voltage value, we can control the behavior of LEDs green and yellow accordingly. In the Arduino real-time environment, we can employ the task scheduling principle to manage these tasks in a real time. Each task is assigned a specific period to ensure timely execution and maintain system responsiveness. Additionally, we display the measured voltage value and task execution detail on the screen, providing a valuable tools for monitoring and troubleshooting the system. The equipment and tools. In our mini project, we utilize a PC workstation equipped with the Arduino IDE along with a real-time extension to program and control the Arduino board. The setup integrates with various components such as 10K ohm potentiometer, 10K ohm resistor, 220 ohm resistor, LDR sensor, green LEDs, and yellow LEDs. These components were interconnected on a breadboard using jumper wires.
Hello, my name is MOHAMED. So I will explain about this executive summary. For the first point, we aim our project to create a real-time system base given in the diagram from mini project. So the system are allowed to manipulate of the green and yellow LED using the variable resistor. That means to control the power voltage, and the LDR sensor to control input voltage V in based on the humidity light. So the measurement value for V in 0 and V in 1 so are predictably displayed on the serial monitor. The tools and the equipment used for the project include with the PC workstation running the Arduino IDE and the RTA, and Arduino Uno board with the 100 kilo ohm on potentiometer, a breadboard LDR sensor, a serial monitor in the Arduino, and green and yellow LED. So the result to indicate that both LED remain off when the voltage controlled by on potentiometer and LDR sensor is below than 2.5 volt. So the green LED turns on when the voltage controlled by potentiometer and LDR sensor is between 2.5 volt and 3.3 volt. So the yellow LED turns on when the voltage controlled by potentiometer and LDR sensor is above than 3.3 volt. So I will show the block diagram. As you can see, the potentiometer is the input, also the LDR. Why we put the input? So the potentiometer is to control the voltage. So also the LDR sensor, when we close the LDR, so we get the result for the dim of the light. So this is Arduino Uno as a process, and this is for output. As you can see, the serial monitor, we show the result of the voltage when we get the control the voltage and the result for LDR sensor. So we have the 4 LED, which mean to execute while we control the using the analog signal using the potentiometer and LDR sensor.
Hello and good day, sir. My name is Tommy Lee, and I will continue with explanation of the schematic diagram of our mini project. So as you can see here in the middle, we have our Arduino Uno. So connected to our analog 0 here is our potentiometer, and to analog 1, A1, is our LDR sensor. Okay, so for pin 13 is yellow LED. Pin 12 is a green LED. Pin 11 is second yellow LED. And pin 10 will be the second green LED. So all of this will be connected to the ground. So when we execute and run the circuit, so as you can see, when V in 0 and V in 1 when we set the voltage to in between 2.5 volt and 3.3 volt, as you can see here. So both green LEDs will light up. So at the serial monitor here, as you can see when we run, so when it starts with task 1, the voltage of the LDR is between 2.5 volt and 3.3 volt. So the green LED will light up. So it will end task 1. When it starts task 2 here, the voltage of the potentiometer, we set it to in between 2.5 and 3.3 volt. So the same, it will light up the green LED. So as it continues until the end of task 1 and task 2. So next, when both V in are more than 3.3 volt here, so both yellow LED will light up. So as shown in the serial monitor here, when it is detected more than 3.3 volt, so all yellow LED will light up. So until both tasks ends. So all of this happens in real time. And next, when both V in are below 2.5 volt here, when we execute the task, so when SIM monitor detects both LDR and the potentiometer are below the 2.5 volt, so it won't light up any LED at all. So you can see at our outcome here, all the LEDs are not light up.
Hi, my name is MOHAMED from MOTARI. I will be presenting for the discussion in this project. We have faced some issues to run this project properly. Firstly, LED not lighting up correctly. Then we resolve this problem by changing the resistor that have connected to each LED. Second, the serial monitor not display the input voltage. Therefore, to solve this issue, we connecting all components to the ground of the circuit. Third, the serial monitor becomes stuck at the input voltage is 3.3 volt. So we have solved this issue by restarting the system. Finally, after all the issue has been resolved, the project demonstrates the effective implementation of real-time on Arduino, showcasing LED control based on the input voltage value and accurate voltage measurement using the serial monitor. For the conclusion in this project, we have able to design and construct a real-time using an Arduino board, variable resistor, and a LiDAR sensor for the input voltage measurement. So in this project, we design our circuit by using voltage 8 for schematic diagram, and then we apply to the physical experiment. Then we have learned how to use variable resistor and LDR sensor voltage value to control LED. After that, we have learned how to use the serial monitor to monitor and debug voltage value and task execution. Finally, we have able to apply scheduling principle to schedule and prioritize the system tasks in the Arduino real-time environment.
So for our recommendation on this mini project, potentiometer are recommended as a variable resistor for the project due to their ease of use, small size, and affordable to compare the other option. And point number 2, we conducting the project in a dimly lit room is advisable to optimize the performance. Higher light intensity decrease the resistance value of the LDR sensor, allowing to control voltage more effectively. Directing a torchlight towards the LDR provide sufficient light for this purpose. Point number 3, lastly, we address the synchronization issue between the potentiometer and the LED, replacing the 10K resistor with the 100K resistor to resolve the problem.
Here is a live demonstration of our circuit. So for potentiometer, starts at below 2.5 volt, and when we increase to between 2.5 volt and 3.3 volt, task 2 will show LED green is on. So the serial monitor here shows that the condition has been met. And next, when potentiometer is being turned above 3.3 volt, so serial monitor will show LED yellow is on. For the next part, for LDR sensor, so it is task 1. So when it is below 2.5 volt, both LED will turn off. So when we uncover the LDR sensor, so once the voltage reaches between 2.5 volt and below 3.3 volt, LED green will turn on. And we add more light source to the LDR sensor using a flashlight, and afterwards the yellow LED will turn on.